Hello and welcome back to the Maths Behind the Economics YouTube channel and the Logarithms for Economics series. This is video 7 and in this video I'm going to list you all the different log rules. I hope you'll enjoy it. So let's get down to business. The first rule is about what to do when there is a multiplication behind the log sign. I'm going to show you two different versions, one with a generic log base, and what it means is if I have got a log, let's say with base b, and I have got two numbers multiplying behind it, let's say x times y, then that basically means that I can write this expression as a sum of the same bases, but with the individual numbers behind each of those log signs. So log b x times y is going to be log b x plus log b y. So what does it look like in the case of the ln, which is just going to be a special case? So in the case of the ln, it would look like ln, we know that this is e base, so we don't need to write it out, x times y will be equal to ln of x plus ln of y. The next rule is to do with division behind the log signs. So again, the generic case, if I have got log whatever base x over y, which is again division, then what can we replace this? Well, we can replace this as individual logs with the same base, but now subtracting those log bases with the same bases with the single arguments now. Now, the special case would be when we use the ln. So ln of x over y, and I can write it with or without the bracket. It means exactly the same. And this would be ln of x minus ln of y. Let us make some more space so we can move on to the third rule. The third rule will be all about how do we deal with exponents behind the logarithm sign. So let's look at the absolute generic case. So what happens if I have got some log base, I don't know what, so I'm using just b for it, but now in the argument I have got some number to some power. Okay, so basically what happens here, I can bring the power down in front of the log sign, and then I'm just gonna keep the log base with x behind it, just the single argument without the exponent. So the exponent in the argument comes down as a multiplier in front of the log. Now there is a few special cases here that I would like to show you. So what happens with the ln? So if I have got ln x to the n, that's just going to be n times ln of x. So again, just because it's e-based logarithm, the rule stays the same. In this next version of the rule, probably going to look a little bit unfamiliar, but bear with me. If I've got log b 1 over x to the n, that is just going to be negative n log b of x. Now, I hope that you have followed through with our exponents series, and from that you can probably recognize that 1 over x to the n is just x to the negative n, so that's basically just rewriting x to the n to x to the negative n and then applying the rule inversion a in here. Even though it looks slightly different, in principle I'm using exactly the same rule. Now, I would have a special case for this as well, when I would be using the ln. So ln 1 over x to the n is again just going to be negative n times ln of x. Now again, we're going to need some more space, so we can move on to the next rule. In the next rule, we're going to deal with roots behind the log sign. So the most generic case would be log base b nth root of x. So what's going to happen in here? Well, it's going to tell us that this has to be equal to log base b x over n. Now, if you remember what's the connection between roots and powers, you probably spot where the rule is coming from. But don't worry, I will explain every one of these rules in details in the following videos. So again, make sure that I clearly show you the special case when we use the specific logarithm with base e or ln. So ln of nth root of x is just going to be ln of x over n. Now, I can take it one step further and I can talk about log base b nth root of x to the m. Now, what would happen in here? Well, this would be equal to m times log base bx over n. And again, I suggest that you start to think about why this rule might be true. Okay, so just try to think about how we can combine roots and exponents. And again, just for the sake of completeness, let's write out this same rule with base e. So, special case with ln nth root of x to the m, and again, make sure that we use the bracket, is going to be m times ln of x over n. Again, we're going to need a bit more space. Let's do just that. And now we can move on to the fifth rule, which is going to detail what happens when we have got the same base and the same argument. So, in the generic case, if I have got log base bb, well, that's just equal to 1. And remember, we already covered this in video 5 in details, so if you have forgotten or you haven't seen it, then take a look. Special case for this with ln will be ln of e being equal to 1. Remember, ln is base e logarithm. Now, the next rule is all about what to do with logs when we have got 1 in the argument. So again, to be consistent, we're going to start with the generic case. So what happens if I have got log base b1? What is that equal to? Well, again, from video 5 of the log series, we have covered it in details, so we know that any number to the 0 power is always equal to 1. If you have forgotten why this is true, just check out video 5 again. Now, look at the special case of the natural logarithm. So ln of 1 is going to be equal to 0. Again, we're going to need a little bit more space, so let's do that. And look at the next rule, in our case 7 now, and see what happens when we need to change the base of a logarithm for whatever reason. So, for example, if you have some log base x, how can I rewrite this as a different base log? So, for example, if I was to change the base to a, what would this look like expressed as base a? So, it would look like log base ax over log base a b. So the argument is in the numerator and the old base is in the denominator, to both which I'm going to apply the new base logarithm. So again, what would it look like with the special case of the ln? So what would ln x look like when I would need to express it as a base b, for example? So remember, log b is now my new base, but to the numerator goes the argument of the old log, which was x, and to the denominator going the old base, which is e. Both of them are expressed as logs of the new base. So log bx over log be, where e is the old base because ln is base e. I've got a few more rows to go, so again, need to make some more space. And let me show you how can you deal with logarithms where there is an exponent in the base. So what would happen if I had a log where the base is to some power? Well, that is just going to be equal to 1 over n times the logarithm without the exponent and the same argument. And again, express this very same rule with the natural logs. So the log base would be e to some power. The argument would be x, could be any number whatsoever. And then that would be equal to 1 over n times ln of that same argument x. Our next rule, which is the 9th on the list, I'm going to show you when would logs, more than one log, so when would different logs cancel out to 1. So in this case, let's say I've got a log base b x that I need to multiply with log base xb. Well, this will always cancel out to 1. Let us just pause for a moment here and see what's actually happened in here. Well, the base of the first log is the argument of the second log, and the argument of the first log is the base of the second log. So if that is the case, the two logs when multiplied together will always cancel out. And in one of the future videos, I will show you exactly why this works. Now let me write down to you what it would look like in the special case of ln. So if I had ln x, what would I need to multiply that by? So that answer would be 1. Remember that in the generic case, the arguments and the bases swapped place. So I need to now write log base x e, and then this way the 2 will cancel out to 1. Remember, ln is base e. So that's how I swapped the arguments and the bases in the second part of this expression. I've got one more rule to go, so I'm going to make, again, some more space. And let us write out when logs and exponents cancel out. So in the generic case, if I have got log base b to the x, that's only going to be equal to x. Again, what does it look like in the special case of ln or natural logarithm? Well, that would be ln e to the x just being equal to x. A slightly different version of this, when I have b log base bx, again cancelling out to x, and in the case of ln, what would this look like? Well, that would be e to the ln of x going to be equal to x. And if you have watched the previous video 6 in the logarithm series, then you're already very familiar with this. I just wanted to make sure that I list every single one of the rules in one video. Now, in the next video, we'll start to discuss these rules in details, and I'm going to show you, going to prove you why each of these work. We're going to start with the multiplication behind the logs, which was our rule number 1. Thank you for watching this video. I hope that you appreciate having all the rules in one video, and some of the rules you may or may have not seen previously. I just hope that in any time in the future, if you need to quickly find all the rules, then you turn to this video. Thank you again. See you in the next video. Bye.